Hi, everybody. Welcome to the Ubiquity Dev Summit, Day 1. Before we get started, I wanted to tell you a little bit about our code of conduct. We want everybody here to have the best experience possible, and we value an inclusive community. No matter your background or experience, you're welcome at the summit. And we encourage you, therefore, to be excellent to each other and know that we have a zero-tolerance policy for any harassment of any kind. Our code of conduct is posted around the venue and on the website. All right, and with that, I'd like to get the conversation started with a colleague who couldn't be here in person today.
Hi, it's Vince Cerf. I'm Google's chief internet evangelist, and today I want to rant about the Internet of Things. You're going to hear a lot about this, and from me, you're going to hear several things. Specifically, you're going to hear that things need to interwork. Nobody wants a million different hubs that they have to configure for each different product from each different manufacturer. We're going to have some standards, international standards, that will allow people to manage and configure and control access to these devices, which leads me to another point, which has to do with security. It's important that these devices be updatable so that bugs and mistakes that might leave them vulnerable can be corrected. But that also means that when the device ingests a new load of software, it has to be able to make sure that that particular load is legitimate. So we need to digitally sign things. We need strong authentication so that a device that's getting a new software load knows where it came from and can assume that it's a safe load to install. By the same token, I'm very concerned about privacy, and the reason for this should be obvious. There's a lot of information that even sensors could collect, like temperature sensors where you're sampling every 5 minutes. After a while, let's say after several months, you might be able to figure out how many people live in a home, which rooms do they occupy, what is their typical schedule for coming and going. But on the other side of that, suppose the house is on fire and the fire department comes and wants to know where is everybody. Some of them may be unconscious, so if there's a way to tell who's in which room, or at least that someone is in a room, that might turn out to be a life-saving piece of information. So we really need to make sure that as we design these devices that are part of this Internet of Things, we pay close attention to interoperability, strong authentication, privacy, and security, and safety, so that the users will have confidence that the devices they buy from us and others will in fact be things that they can rely upon. That's a big burden on everybody's shoulders, but it's a responsibility and an obligation that we must undertake. Otherwise, no one will be interested in buying and using the products that we make and want to sell. So I hope you have a great conference. I'm sorry I can't be there with you, but I hope I'll see you on the net.
Thank you to Vince Cerf for getting our conversation started. Now, I'm going to continue it with a little bit more detail in that context. Let's start with this question. Have any of you thought about what the living room of the future will look like? Lots of yeses. Give me some ideas.
I'll be a couch potato.
I'll be a couch potato. What will the living room of the future look like? Any other? Yes. Apps.
It'll be automated.
Automated.
Basically, turn on your favorite television shows if you're in the mood for TV or
It'll be automated. It'll know your favorites and your preferences. These are all great ideas. And it's interesting, actually, when I usually ask this question, people focus on the technology. And, I think that's key for us to do. But here's what our colleagues at Nest came up with when their CEO, Tony Fadell, asked them the same thing. I really love this picture, and I'll tell you why. It's a little messy, it's a little playful, but the most profound thing is what it isn't. Right? There aren't screens and keyboards everywhere. You can hardly see the technology at all. Instead, it fades into the background, supporting the users, this family, in many subtle and effective ways. So when you think about ubiquitous computing or the Internet of Things, don't think about technology getting in the way everywhere or being overwhelming. Think of it blending in and helping everywhere it makes sense and is useful for your users. With that in mind, here's 3 pillars for us to start our journey together. And it's been my experience that the most successful companies that I've observed and met in this space, these are the 3 things that they're most passionate about. The first of which is interoperability. This is systems, protocols, and IoT schemas that are based on open standards and enable interoperability as well as modularity. The second is security and privacy. Data control, access control, and identity management are fundamental, regardless of who made the product or how users access it. And the last one is human interface. And this is all about new paradigms for HCI that rely more on natural metaphors. Let's dive into a little more detail on each of these three pillars. First, interoperability. Now, historically, engineering teams have built their own solutions to solve their own problems, each creating their own proprietary protocols and further isolating their devices from the rest of the world. However, if you have common IoT protocols, not only does this mean less work for the device manufacturers and app developers who no longer have to keep solving the same problems over and over again, it also means that these devices can talk to each other, and app developers can integrate multiple devices into their feature set. Next is security and privacy. Now, this is all about having everything be secure and giving users the right insight and options to control their experience as appropriate. In a little more detail, what that means is hardware and software makers should provide security and privacy by default, building in essential platform features like over-the-air updates. We need to build user trust at every turn so that they're confident of the security of their data. And we should provide users with the controls to manage their digital identity and data per sensor, per account, per product, and per home. And finally, we need to ask the user before sharing any data with other devices or services, and of course, this helps build user trust. The last pillar is human interface. And this is all about new paradigms for user interface and interaction design, or you can think of it as a reliance on more very old paradigms of natural interface. And a common pitfall here is to build an app walled garden. Now, apps are important, and we'll have them for some time yet, but think about building a platform, right? And part of that is through your app, and part of that is that users can access their devices in a variety of other ways, including physical interfaces and other apps and services. Also, here's some design principles for really great user experience on IoT. First, the user experience should be so simple that it feels effortless. In the long run, users always prefer simplicity and reliability over features. And whatever user problem you solve, make sure to focus on that and never let anything get in the way of that effort. A great example of this is messaging, right? And you'll see this on a variety of platforms. I, of course, love the experience on Android Wear. In particular, I love just being able to see the message on my watch and be able to respond to it with voice. It's so simple, it just makes sense. The next one is contextual. Now, contextual is all about being relevant, right? You want to take into the account the time, location, and activity the user's involved in so you can provide them with the most useful experience wherever and whenever it is. A great example of this is you can imagine a shopping list where the user walks into the store and the list just comes up for them. Right? And before they leave the store, it reminds them of anything that they might have missed. In this case, you're providing information and experience for the user before they asked for it. And finally, it should be immediate. The experience should be so fast that it feels immediate. Being contextual can help with this, but it's also about micro interactions. And remember, you're not trying to distract or occupy the user. You just want to present the right information right away so they can get what they need and get on with their life. A great example of this is voice commands on Android TV. I can just tell Android TV what show I want to watch, and it shows me that in my library. Or autoplay and queuing with Google Cast. So the next episode just comes on right away as I'm watching through a series. All right, here's the last one, extensible. Now, I've mentioned this a few times today in a bunch of different ways because it's really important. You want to build your app so that the experience is extensible. That means the user can get to it wherever they'd like. And you want to build that into your core app and overall experience so that the user really has it at hand wherever it makes sense for them. A great example of this is music. Can you think of a time in your life where you wouldn't want access to your music? Right? Whether that's like on your phone, going for a run, in your living room, or in your car, You should be able to, as a user, have that music experience in any of those contexts in the way that it makes sense in that context. So these are our 4 principles for UX design, human interface, that we can keep in mind, keep in our pocket as we build in this new space. And with some more detail about that, building in this new space, I'd like to welcome to the stage Gayathri Rajan, Vice President of Product at Brillo and Weave.
Thank you, Timothy. Hello, everyone. IoT is here, and it's pervasive. These things will soon outnumber phones, tablets, and laptops. Or to put it another way, in just 5 years, there will be 26 of these smart devices for every human on the planet. So that's the good news. But there are significant issues today that could hurt adoption of IoT. A survey conducted on IoT executives highlighted that the top barrier, the thing that they're most concerned about for IoT adoption, is interoperability. There are simply too many fragmented protocols and siloed ecosystems today. It's also important to note that security concerns are a fast follow. And if you ask consumers, they'll say they still don't see the promised value. But where there are problems, we and you see opportunity. The opportunity that lies ahead for IoT is to rethink those user experiences in fundamental ways. First, reimagine the products themselves. Look at ways we can make the devices themselves smarter with the power of the net. And second, choreograph these experiences across ensembles of objects and services so that in concert we can create true user benefit. But in order, oh, I forgot to do that. So let's, as an example, let's take something as utilitarian as a washing machine. If we were to add connectivity and the power of the net, you could reimagine a smarter version that is activated by voice commands, that understands the user and its context, that knows when it's not operating efficiently. Now let's amplify this further by orchestrating experiences with other services and devices. The washing machine now learns about the activity in the household and its energy use, and can then determine when to start the wash cycle, when it's optimal for household convenience and energy savings. It knows when to order detergent when it's close to being exhausted, and it can do that automatically. The possibilities here are endless. I think this audience will have ideas that take this a whole lot further. But to get to this vision, we believe openness is an imperative. You've heard this before, but we think this bears repeating. These devices must be able to communicate with each other across brands. And the data that they generate must be comprehensible, so developers can scalably build intelligent services on top. Which brings me to security and user privacy. In this interoperable ecosystem with all these devices from different brands connecting to each other, security becomes increasingly critical and must be built into the devices themselves and the device interactions. It should be really easy for users to control who and what can access a device and exactly what they can do with it. User and device data must be protected from unauthorized access, be the data stored on the network, on the cloud, or on the device itself. Really, really important that it's protected. And finally, the device itself must be made resistant to attacks. And in the event of a compromise, it should be really easy to fix it and bring it back to a trusted state. Which brings me to Brillo and Weave. Brillo and Weave is Google's approach to building for IoT. We've built security features into the Brillo and Weave platforms, so you can use it to build secure devices and device interactions. And we've deliberately made Weave an open protocol, so it's easy to build apps and services to securely set up your device, control them, and choreograph those experiences across different devices. But ultimately, our vision for Brillo and Weave, and this is really important, is to enable our partners and the larger developer community to build those great devices and experiences that users will love. We provide the foundational elements so you can create the magic. Just to give you a little bit more of an overview of what Brillo and Weave are, for those of you new to Brillo, in a nutshell, Brillo brings the simplicity and speed of software development to hardware for IoT. What we give with Brillo is an embedded, secure OS, core services, and a developer toolkit, so you can build your IoT device. And because Brillo is based on the lower levels of Android, it's supported across a range of hardware. So in addition to helping you build these devices, with Brillo, you have access to tools to help you monitor and manage your devices over its lifetime. Really, really important in this new world of connected devices. We can't just ship and forget. In particular, we provide a really easy way for you to update your device over the air. Those of you who've been building your own hardware know that this is hard to do reliably and at scale. And we believe updates are the only way you can ensure that the device stays secure over its lifetime and can recover from attacks. So that's Brillo in a nutshell. Weave is a communication platform for IoT devices. It provides a seamless and secure way for users to provision their devices onto the network, something a lot of users struggle with because today it's pretty inconsistent, device to device, and controlled low latency access to devices both locally as well as remotely. Weave is built into Brillo, which you can also use the Weave libraries on an existing device operating system that's based on Linux. On the client side, Weave APIs and the SDK are available on Android, iOS, and the web, so you can build apps for all these platforms. And because interop is such a critical element for IoT, what we've done is, for Weave, we've created these device schemas for major device categories. In this case, you see an example for a camera and for a lock. This makes it easy to build applications that can interact with Weave-compatible devices regardless of brand, and easy to choreograph those interactions across device types as well. So that's the basics of Brillo and Weave. You'll hear a lot more details in upcoming talks today and tomorrow. Over time, we'll be adding a lot more in terms of services to Brillo to make it easier for you to build smarts into your device. We'll be adding some really cool stuff, for example, voice actions, now like contextual triggers, so you can build some of those experiences into your Weave-compatible app. So look forward to hearing more from us. Essentially, with Brillo and Weave, as I said, we're laying the groundwork so device makers and developers and you in the audience can build the IoT devices and experiences of the future. This is a problem that we share, and we believe that there's a great opportunity to solve it together. Now, just to give you a quick sense of the possibilities, I thought I'd show you a demo of a Weave-enabled device. That's a dog feeder there, and a Weave-compatible app. So for context, Wayne's a member of our developer team, and he's an owner of 2 very energetic and hungry dogs. He'd bought this dog feeder a few years ago with the intention of getting it set up and connected to the internet, and the technology was too hard at that time, and he'd given up. So it was sitting in his garage, gathering dust. He brought it in for this demo and got it Weave-enabled in under a day. So let me welcome Wayne, and oh, we have a surprise guest, Monty, on stage. So I'm going to show you how easy it is for Wayne now to feed Monty when he's, well, when he's at work. Can we switch to the phone, please? So that's his app, his Weave-enabled app. And all he has to do is click on this button and feed Monty. Well, It's easier to do the technology than get adoption, isn't it? So that was a really simple demo. To give you a flavor of what you can do, I encourage all of you to use this opportunity over the course of the next 2 days to learn more about Brillo and Weave, work on the code labs, ask questions at office hours. You'll have access to Brillo and Weave very soon later today. So this will get you an opportunity to get your hands dirty. We're really excited to see what you can build with Brillo and Weave. Thank you. Timothy?
Thank you, Gayathri.
Thanks.
And Wayne and Monty. Next, I'm very excited to welcome to the stage Rajat Monga, technical lead for TensorFlow. You can clap. That's okay.
Thank you, Timothy. Thanks. Hello, everyone. So I'm Rajat. I'm on the Google Brain team, and I work on TensorFlow. I'm the lead for TensorFlow. Gayathri, talked about a lot of devices that are going to be there in our future. She mentioned like 26 smart devices for every human on the planet. Well, I'm here to help make them smart. Help you make them smart, really. So let's talk a little bit about machine learning. Why is it so important, right? Why do we care about it? Why is it such a big thing today? So let's start by just talking a little bit about what machine learning really is and what it can do for you. One way to think about it is, if you want to solve tasks that you can't really just program, as a developer, right? That's what you want to do, to program everything and be done with. This is something that can really do that for you. So for example, the examples I have here is, you have a bunch of images, and they're labeled. If you wanted to program something that could take those images or take a new image and say it's a dog or a cat or whatever, that's going to be really, really, really hard. But you can train computers using what's called machine learning to really do that, where you have data sets which are nicely labeled images. You feed them to a computer with the right algorithms, of course, and then eventually out pops a model that you can use to classify a new image that it's never seen before. And it's used in a variety of places to do that. So now let's talk a little bit about what are the different things that you can really use machine learning for. What is it being used for today? So one of the things, just going back to the example I was doing, is image recognition, right? You can, in this case, give a picture of a lion, and it can say it's a lion with a very high confidence, and it does really, really well here. In fact, on a data set called ImageNet, which is very popular in the research community, which has about 1 million images and 1,000 different classes, the human accuracy is supposed to be something like 95% or so. And these models are now able to surpass human accuracy on that particular data set. It's not that general. I mean, it can't really see as well as you do for every little thing. But at least in these kind of images, it can do better. So it's getting really, really good. Another one is voice. A lot of you have probably already tried talking to your phone, doing searches, asking Google what's going on. In this case, somebody's asking, OK, I want to see Seattle restaurants. And it uses machine learning to really take your voice command, the audio that you have, and convert it to a query, which is then fed to the regular Google search engine and give you the great results that we are good for. Another is search. The web now has something like 60 trillion pages. The last I checked, it's probably a few more trillion by now. Finding the relevant documents from so many different pages is a hard task, right? Google's done it really, really well. One of the things that helps us there is machine learning again. Given a particular query that you make, sorting and sifting through those trillions of pages, and then coming up with 10 answers that we can show on that page, because that's all you're going to see, and maybe go a few more pages, is really a hard task. And machine learning is a great way to help solve that. Another one is translation. So if you ever tried Google Translate, where you just type a query, or you just type something in, say, English, it can translate it to French, or the other way around. And in fact, it supports 90 different languages today. I don't think we could do that with even 1 million people sitting behind and sort of translating those things for you. So again, one of those things that machine learning has made a huge difference. Another newer one is, and this one's more researchy so far, is taking an image and actually trying to describe that. And in this particular case, as you see, there's it's able to describe a close-up of a small child just as a human word, right? And it's getting really better in things like this. Think of the kind of impact something like this can have. If a visually impaired person who can't really see can be described everything that's going on around them, it'll just be a game changer for them. It'll be a life changer for them. So these are some of the things that machine learning can do for you. Now let's go a little bit deeper into one specific branch of machine learning called deep learning. And the reason I go through this is all the things that I just talked about, they are actually, deep learning was applied, and deep learning was the one that got all those great results for us. This is a very old technology in the sense that the core ideas come from the 40s. It was called neural networks or artificial neural networks back then. Over time, it's evolved both algorithmically and with the additional data being available and the computational power that's available to us. And it's continued to improve. Especially over the last 5 years, it's starting to show great results, like in some of the fields you saw, and I'll show you some more later on. The basic idea here is you have some input of all kinds of things. It could be images, speech, text, all kinds of things. You build these networks that extract features out of them and are able to make some sense, and are finally able to make some predictions of whatever you're interested in, whatever you can train it for. And they're pretty widely applicable. The same kind of algorithms are applicable across a variety of different areas. It's very loosely inspired by neuroscience. Some people might say that's how the brain works, and we're trying to replicate the brain. Not quite true. I wish it were, but not quite there yet. It is definitely inspired from there, though. This slide is just to give you an idea of how important it is for us at Google. We started this group back in 2011, and it's been growing rapidly since then. It's, as this shows, this is just a rough idea of how many different teams are using it, but the number of different directories that have models built off of this technology, and there are all kinds of applications and areas that are using this technology. So that's great. So, I've now given you a background of what machine learning is. Now let me dive into something called TensorFlow. It's a machine learning library that we just open sourced recently, and I'm going to talk a little bit more about that. So let's start with what is TensorFlow. It's a library that lets you do all the things that I was talking about. It's a library that that allows you to build these machine learning models and deploy them in production. And it powers hundreds of different products at Google today. I listed some of the names of areas that use that, but there are many, many more. It is something for researchers to try out new things, to build new things, but also for developers to deploy these models into production or applications or products, whatever you have. And it's really important to be able to do that. With all of this put together, what it allows us to do is really to build the next generation of intelligent applications, right? We have a lot of different applications. We have a lot of products. How do we make them intelligent? How do we make them smart? That's our goal. We want to help enable that. And we did open source it, so it's available to you now. We open sourced it a couple of months ago. It's on GitHub, and I'll give you some pointers at the end of the talk. But it's there for you to try out, to do a lot of things with. So let's talk a little bit about, what does it give, what does it have, what is TensorFlow, right? At the core, like you see in the middle, there's the core execution engine that's written in C++ for raw performance, right? We definitely want to extract as much performance as we can out of wherever it's running. On the front end, we support many different languages depending on whatever the developers want to build things in. In some cases, it might be C++ because they want the absolute last bit of performance. But in other cases, it might be Python because the data scientists and the researchers, that's what they're most comfortable with. And they want to really try out many different things. They don't want to have to recompile things and so on, right? And the way we've built the core is to enable supporting many, many new languages as well. In fact, we are working with the community to add support for many different things. People are interested in Java, and JavaScript, and Scala, all kinds of things. And you'll see support for more of these building up over time as well. Now, one of the things that the core execution engine does is it abstracts away whatever the underlying devices are. So it actually runs on all kinds of platforms. It can run on your Android phones, on iOS phones, on all kinds of iOS devices, and on your workstation, on your data center, et cetera. It's it's pretty platform independent that way. So you don't have to worry about what platform you're using or where you want to deploy. You can use it everywhere. The core was built, our goal was to build it for machine learning, but the core is very general purpose, and in fact, people are interested in using it for other things too, but I'm going to focus on the machine learning aspects of it. And the basic idea being that really makes it really, really flexible. So even if you want to do machine learning, it allows you to expand and try out all kinds of things that you would want to do. So that's great, seems like a great product. One question we always get is, Google uses it so much, why did we open source it, right? So as you saw earlier, this is having a huge impact at Google. So many different teams are using it. We thought this could have a much bigger impact across, outside in the world, outside Google. And it's really important for us to enable the kind of research and, to accelerate machine learning and to do even better than where we are. Yes, we are building smarter things. We are building applications that are learning a lot, but there's a long way to go. There's still a lot to be done. And we definitely want to accelerate machine learning research, and that was one of the reasons why we open sourced TensorFlow at this time. The other part that we think it's really important, and we've seen at Google, by having this one platform that goes from data scientist to the developer, is that it speeds up production deployment. Once you make something, once you have something that's working, you really want to deploy it as soon as you can. You don't want to wait another quarter for the developer to build something that can be deployed in production. And this really helps with that. So digging a little bit more into that, who is it for? It's really for all kinds of people. And in this case, we talk about the researchers, developers, and the data scientists. And what the researchers do, of course, is they want to try out new ideas. And this provides the flexibility for them to do that pretty easily without having to worry about the underlying frameworks, the performance, et cetera. It just comes for free. Now, the data scientists, who are probably overlapping with researchers, et cetera, can leverage the growing library of models that we've built. And what we are doing is, as we publish papers on new research, we're also going to publish real code that can be shared and collaborated with. Now, other data scientists can leverage that, customize it to their needs, or train it on their specific data, and really gain a lot from that. Once that's done, once they have a model and some that works really well, that gives great results, then the developers could take the same API and use it to deploy it in production. So here are some examples of applications that actually use it today. In some cases on the phone itself, in some cases in the cloud. Google Photos for one, for example. In this case, you can search by saying a dog, and it'll show you pictures of the dog. It organizes things by the different people, et cetera. And all of this uses machine learning behind the scenes. Another one is Google Translate, which uses a combination of cloud and on-application or on-device thing. So for example, in the case on the left here, you can just point the phone at at some sign, and you'll be able to just see it translated in your language. In this case, it's converting from, say, French to English. And in this case, you want that real-time feeling, right? You don't really want the user to point the camera and then wait for 2 seconds before it goes to the cloud, comes back, and then displays this. It actually, in this case, real time, just takes the image and superimposes the right text on it. And so in this case, having it on device is really, really important, and you can do that with TensorFlow. Another one is just, conversing hands-free. You're talking to the phone, and it can speak the other language for the other person as well. Another one is, in Inbox, we launched a new feature a couple of months ago. It's called Smart Reply, where if there's a small text, small email that you got, and you have a very, very simple reply that you could send, it's going to give you some suggestions, and you can just click on the suggestion and take it if you want. And it makes it really easy to reply to emails from the phone when all you want to say is, OK, I'm going to be there, or in this case, say, I'll check on it, or something like that. Another one is Google Keyboard, where it predicts what you're saying. For example, you might swipe on the keyboard, and it's going to try to figure out what word you have and what word you're trying to say, and it can do that using machine learning. So one of the things I wanted to leave you with is, I showed you all these different applications in different areas that we've been applying machine learning. All of these applications today use machine learning in one form or another. And this is not a small list, right? People say that the future is going to be smarter, and in the future, in a few years, we'll have very smart applications. I don't think that's really true. I mean, yes, they are going to get smarter, but you already have smart applications today. You already have smart products today. And you really want to think about how can you make your application smarter when you build the next one. If you're building an app, if you're building a cloud platform, whatever you're building, you really want to think about machine learning to see how it can help you make your next application smarter. Thank you.
Thank you, Rajat.
Thank you.
And we have one more speaker for you today. I'd like to welcome to the stage Chandu Thota, who works as an engineering director for geolocation and local efforts at Google.
Thank you, Timothy. Good morning. So today we are going to talk about beacons. How many of you have seen beacons? How many of you have used beacons? Okay, hopefully we can change that after the session and after the conference. So beacons are not new. So they have existed for a long time. And in fact, the platform that we have built at Google called Eddystone is a name that has been derived from a real lighthouse that was built off of UK some 300 years ago. Beacons have been critical and fundamental infrastructure in providing context in real life. Whether you are sailing the seas, that's where they were used some 300 years ago, and even today there are a bunch of beacons, that the lighthouses that people use when they are in rough seas. But there are also beacons that people use when they are navigating on the roads. So if you are using any GPS nav unit, most likely you are using a bunch of beacons in the sky. And these are what we call GPS or GLONASS or any other system that have been designed to provide this context. And the context is not necessarily just about precise location. So even though most of us actually think, whenever we think of a GPS or any beacon, we think of that as a tool to provide precise location. But the reality is that they can provide a lot more context. Even in the case of GPS, you get obviously a precise lat long, but also you get the heading and the direction and so on and so forth. So there is a lot more context that is provided by beacons to your applications that you're using. But here is a fact. We have all these navigational aids and contextual aids that are present they have been present for hundreds of years, and they are present in our life today through various means. But the reality is most of them are designed for outdoors. Whether you are take lighthouses or GPS, it's all for outdoors. None of that works indoors. And the reality is that 90% of our wake-up time, the active wake-up time, we spend indoors. And for that, and also because we use a lot of mobile devices with us all the time when we are indoors, we need a better system that can provide us that precise location and context so we can build our apps that can be smarter and useful. And when I say precise location, you are actually thinking of lat longs probably, but that's not actually true when it comes to indoors. There is not a really meaningful application to lat longs, for example, in this conference center. What you would like to understand in terms of a precise location when it comes to indoors is a semantic location. What it means is that I am standing here on this stage. This is a semantic location, the stage, right? And you are sitting in that chair. That is a semantic location. You being able to understand semantically where you are in relative to the physical space that's surrounding you is basically where we are going to use beacons to provide that context. That leads us to many, many applications that we are actually already seeing today in the market. Whether you are in a shopping mall standing next to an aisle, whether you are at the airport trying to find out your next flight schedule or trying to pull up your boarding pass, or whether you are at a museum trying to understand what the painting is about. All these applications are built on top of this understanding of precise semantic location understanding indoors using some type of beacons. And that's where BLE beacons come into picture. If you think about the technology that powers all of this, this is built on top of Bluetooth technology. Bluetooth 4.0 is the specification published by the Bluetooth Consortium, and this is an open standard. And the real promise of this technology is that you don't need to pair with a device, and these devices, anything that implements Bluetooth Low Energy Protocol, are going to consume very small amounts of power. to operate, and these are one-way transmitters. That's the most important thing, because there are lots of privacy concerns about this technology. When it is a one-way transmitter, the device itself is not doing anything. It's only emitting its ID, and occasionally it's saying, hey, I'm here, and that's pretty much what the beacon is saying. And then there is a small payload that you can use in terms of configuring these Bluetooth beacons. That's pretty much it, right? So you have these Bluetooth beacons, one-way transmitter, built on top of a publicly open defined standard, and then they are configured to send messages one way from the beacon to your device on a periodic basis. That's all there is to it. And based on that, we have built a platform to extend the capabilities of these tiny devices, beacons, and make it easier for you developers to build applications that both on iOS and Android to make them more contextual. So the way that we set out to do it is, look, the beacons are open, and the number of applications that needs to be built are going to be very varied. So why don't we start with a very open format? What it means is that each beacon can have various types of frame formats. What it means is that a beacon can emit its ID, or it can emit its URL, or it can emit something else. That 20 bytes of payload, remember from the last slide? So basically, that's the payload that we are going to use, and define a series of use cases together with the community. So that's basically where the open comes from. And we also wanted to make it open source, so you can help us extend some of the frame formats, et cetera, so which we'll talk about. And then we also wanted to make it cross-platform. So it's not just works for Android, but also it works efficiently on iOS. So these are the key tenets of Eddystone beacon platform that we have built. So as I said, this is open source. Open source means that we have chosen to open source the frame formats, the SDK, the samples, all of that on GitHub. So as you can see, there are more than 165 commits to date, and we welcome all of you to come work with us and extend the beacon platform on GitHub with us. And then the frame formats. Frame formats are the fundamental elements of the entire platform. So if you stick a beacon, you can configure that beacon to emit multiple frame formats. What it means is that you can use the same hardware to operate in different modes. So one way is, let's say you take a beacon and you stick it on the podium and say, hey, the podium I'm going to assign an ID, and semantically I'm going to define that this ID means that this stage. And you are going to use that to emit, let's say, once every 10 seconds. And then same beacon, you can also configure that to emit a URL assigned to the same beacon once every 100 seconds, and so on and so forth. So you can use the same hardware and apply various frame formats. So your application listening to that beacon can make use of these different frame formats in building different experiences when mobile apps or users come near them. And we are also working on a series of new frame formats. So this is where, again, if you guys have a specific use case or scenario that you want to work with us, we welcome you to come and contribute to some of these frame formats that may be useful for the rest of the community. And the last one, the key tenet of the Eddystone platform, this has to work both on Android and iOS. So we have nearby APIs, the SDKs available to you both on Android and iOS platforms. And by using these tools, it's fairly straightforward for you to implement your app. If you are programming something on Android, you probably are going to use exactly same paradigms of nearby messages and subscribing to these channels and responding to beacons. All these concepts are going to be exactly the same on both platforms, and that makes it really easy for you to build apps. And how does it all fit together? So there are three layers. There is the beacon hardware, as I described. These are the tiny devices that come from many of our partners. And then there are mobile SDKs. So the cloud service is where you are going to add some more meaning to these beacons. What it means is that, let's say, as I said, if you stick a beacon here on the stage, you can have that ID have a definition of semantic location. So that definition can exist in an app offline, or you can store it in the cloud and say any app that sees this ID have to hit this cloud service and get the meaning of that beacon. And that's where the proximity beacon API service is going to be a hosted cloud service for you guys to register your beacons and attach a bunch of metadata, whether it is semantic location or whether it is a precise location and so on and so forth, so your application knows which beacon they are listening to and then how to react to them. So the way that you would actually proceed with the platform is you take a beacon and you provision it. Provisioning means that you are going to define, pre-configure sets of, at what frequency you want to emit the ID frame, at what frequency you want to emit the URL frame if you have it, and at what frequency you want to emit the telemetry frame, and so on and so forth. And once you have defined that, then you will register with a Google Cloud service and say, hey, this beacon that I'm going to stick here means the stage at the strand. And once the definition is assigned and once the metadata is assigned, you are ready to go with your app. You can take any of the SDKs, Android and iOS, and build your application. And the way it works is the data flow is pretty simple. The beacons are one-way transmitters. They are constantly emitting their ID to your app, where the phone is hosting. And once your Android or iOS phone, the app is running, and it is listening to this any incoming beacon advertisements. And once this message is heard, basically the app going to look up the Google Cloud Service and say, OK, what does this beacon mean? And Google Cloud Service will tell you, here is the metadata you have attached to your beacon. You said this beacon means the stage at strand, or your thermostat at your home, and so on and so forth. Once you have that metadata in your app, you are going to make use of it and do something with it that's interesting to the users. So there are more than 18 partners that we have lined up that can provide these beacons for you. These are all certified partners. Certified means that they conform to the Eddystone standards in terms of implementing all the frame formats, and they also work with our SDK right out of the box. And some of the things that at Google we are doing with this technology, we are obviously wanting to take advantage of this to the fullest extent. So we have integrated this beacon platform into Google Maps on Android, and some of the features that we are just rolling out. We have launched a pilot in Portland where you walk up to any transit stop and you get the real-time transit information in less than 500 milliseconds. So the entire thing was built on top of Eddystone platform, and this is on an Android. And there are Android Google Maps. There are more things that we are trying to do, obviously with Google Now, where you walk into a place and you get notifications, and some of you may have already seen some of the notifications that pop up at a place. So those are the things that we are working on as well. All of this brings us back to one thing, which is, as Timothy has alluded to as part of IoT, beacons are a great way to provide that context, especially indoors. When you are indoors, you are trying to provide the semantic meaning of what you are interacting with or what you are standing next to. As I said, it could be an aisle in a shop, or it could be a thermostat at your home, or it could be a point of sale at your favorite coffee shop. All these things are going to be immensely useful in terms of providing that context into your app. So this is where beacons come into play. And this is where you guys are coming into play in figuring out what can be done to extend Eddystone into providing those powerful contextual apps. With that, we have plenty of other resources available at this conference. We have Ask Me Anything, I think, session tomorrow, and then there is one more developer-oriented session later on today. Obviously, we would love to see you there. There will be members of our team waiting for you to answer any questions. And also, I think Timothy obviously didn't want you to leave empty-handed, so he'll be here to tell you a little bit more about what you got this morning.
Thank you, Chandu.
Thank you.
That's a big box. So what's in the box? Well, we didn't want you to leave empty-handed. In addition to the great sessions and technical information that you're going to hear today and tomorrow, we wanted to make sure that you had the right tools to start building today. So we're giving you a Brillo and Weave development kit, a beacon, and of course, cardboard. Can't leave a Google event without cardboard. Today, with these tools and sessions, let's start our journey together beyond the Internet of Things. Thank you.